Okay, good day, guys. So, this is GE 6114, Mathematics in a Modern World, Week 13, Mathematics of Graphs, Part 1. Okay, let's go with the next slide. Now, these are the objectives of today's or this week's lesson. So, at the end of this module, you are expected to define graphs and its parts, distinguish between complete and equivalent graphs, and identify the path and degree of a curve. Okay, now let's go with the next slide. So a graph refers to a set of points and vertices and line segments or curves or edges. So it is used to represent any scenario, okay, or pattern. So what is graph G? So it is a pair of G where it is equals to V, comma E. Okay? Now, wherein yung V natin would be V of G where it stands for the set of vertices, while yung E naman is E of G, which stands for the set of edges. So as you can see here on the graph that we have on the right side, yung image na ito, it shows a graph or pattern it represents a scenario. Now, if we locate all the vertices, yung vertices are the points, kumbaga, on the graph. So this would be it, this one. So you can see, plinat lang niya yung mga vertices, which is S, U, V, W, X, Y, Z. Okay? Next is yung edges. Pag sinabi nilang edge, that is a line segment. No? So, kumbaga, ang ililista mo, if you were to list the edges of this graph, so you have to list the ordered pair that creates that edge. So, for example, this edge, ito. So, that is X, comma, V. Well, this one is V, comma, W. Ito. And so on. So, yun, nilista lang niya isa-isa yung mga edges. Ito. As long as it's connecting two vertices. That is called an edge. Okay? Now, let's go with the next slide. So, edges may be labeled by a pair of vertices. For instance, E is equals to V, comma, W. Because you can't create an edge or a side in a graph if you don't have two vertices that connects and creates that line. So, E is said to be incident of V and W. So, kumbaga, nabubuo yung E, itong line segment na ito, or this edge, by connecting two incident points or vertices, which is V and W. Now, we have this isolated vertex. Okay? So, it is a vertex without an incident edge. It's just a vertex. So, wala siyang partner na other vertex to create a edge. So, kaya isolated vertex ang tawag sa kanya. Okay? Now, let's go with the next slide. So, these are the special edges. So, first is parallel edges. So, two or more edges joining a pair of vertices. So, for example, A and B are joined by two parallel edges. Okay? So, yung AB would be this one, A and B. So, ito na edge at saka itong edge na ito, itong parang curve na ito. Okay? That is parallel edges. So, loops naman, so an edge that starts and ends of the same vertex. So, for example, or it ends at the same vertex. So, in this example, in this graph, we can say that vertex D has a loop because so it started with point or vertex D, then ends with vertex D. So, that's the definition of loops or an example of a loop. Okay? Now, let's go with the next slide. So, these are the special graphs. No? So, first is simple graph. So, a graph without loops or parallel edges is a simple graph. So, this is an example of that. While yung weighted graph, so it is a graph where each edge has an assigned numerical label or weight. So, ito yung mga edges, so may corresponding weight siya or value. Okay? So, yun yung kaibahan ng simple at saka weighted graph. Now, yung directed graphs naman or digraphs, so wherein G is directed graph or digraph, if edge, if the edge or each edge has been associated with an ordered pair of vertices. So for example, each edge has a direction. So that is a directed graph. Of course, no meron siyang arrow or meron siyang certain direction, yung vertex na yan, where is it going to? So kaya directed graph ito. Kasi nga may arrowheads. Now, let's go with this one. So complete graph of k sub n. So we will let n is greater or equal to 3. So the complete graph of k sub n is the graph with n vertices and every pair of vertices is joined by an edge. So the figure represents k sub 5 because there are 5 vertices and it creates this certain graph. Okay? Now, let's go with the next slide. Connected graphs naman, a graph is connected if every pair of vertices can be connected by a path. Each connected subgraph of an connected graph G is called a component of G. So these are two connected components, no, wherein it is a subgraph of the main graph or the connective graph G. Okay, now let's go with the next slide. Okay, adjacency matrices. So A sub I j, times J or A sub ij is equals to 1 or 0. So 1 siya if and only if V sub I and V sub J is an edge of G, while 0 siya if it doesn't follow this condition. So this is an example of a simple graph and this is an example of adjacency matrices. Now, let's go with the next slide para mas maintindihan natin. So, this is incidence matrix. So, paano ba yan? So, for example, this is the graph. So, label the rows of the matrix, ito, by the vertices which is V, W, Y, and X. Ito. While yung columns naman will be the edges. So, itong E, F, G, J, at saka H. So, next is 1 daw ang value if an edge is incident to a vertex or 0 otherwise. So, ibig sabihin, kumbaga, nabuo yung edge na yun. So, as you can see, itong columns na ito may E, F, G, H, J na edges. Ano yung mga connected sa kanyang vertices? So, sa E, ang connected lang sa E, ito, na edge, is si V at saka si W. Kaya, si V at W lang may value na 1 kasi nga, yan lang yung connected kay E. Kaya, 0, kaya ang nangyari kay X and Y, naging 0. While yung F naman would be, ang connected sa kanya na vertices would be, what? Yung V at saka Y. Kaya, si V at saka si Y lang yung naka-1. While yung G naman, itong linyang ito, ang connected sa kanya is si Y at saka si W. As you can see, si W at saka si Y lang din ang naka-1. While yung H naman is yung X at saka Y. So, yung X at saka Y lang ang nakakonect sa kanya. While yung J naman would be W and K. X. So, as you can see, si W at saka X lang ang may 1. Okay? So, that is for incidence matrix. Now, let's go with paths and cycles. So, pag sinabi natin path, so a path of length n is a sequence of n plus 1 vertices and n consecutive edges. So, yun yung ibig sabihin ng path. While ang cycle naman is a path that begins and ends of the same vertex. Parang loop siya. Now, in this example, as you can see, parang path talaga siya, no? So, parang may puntahan siyang point. So, if we count this, sabi niya dito, path of length 7. So, ang length nito is 7. So, let's count. Paano ba i-count yan? I-count mo yung number of edges or lines wherein nag-change ang direction ng path. So, this is 1, 2, 3, 4, 5, 6, and 7. So, kaya 7, length of 7. While yung cycle of length 9 naman, cycle ito kasi, for example, dito tayo mag-start. So, if we count, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Bumalik siya sa original vertex where it started. And that is a cycle with length 9. Kasi nga, 9 edges din yung na-count natin. Okay? Now, let's go with the next slide. So, yung Euler's cycle. So, an Euler cycle is a graph G, which is a simple cycle that passes through every edge of G only once. Kumbaga, yung cycle na ito, kumbaga the vertices, if you pass through every edge or on that edge, for this, for example, this one, itong edge na ito, so once lang talaga magdaan. May magdaan dyan or may arrow dyan. Once lang per vertex. So that is Euler cycles. Okay. So we're done with Euler cycle. Now let's go with the degree of a vertex. So a degree of a vertex V is denoted by delta V, no, which is the number of edges incident on V. So for example, yung A. So yung A, tingnan mo lang kung ilang edges ang connected sa kanya. So that is 1, 2, 3, at saka 4. So kaya 4 ang answer niya dito. Well, yung delta B naman is this one. So, ang connected sa kanya is ito lang, ito, at saka ito. Kaya 3. So, delta C naman would be 4 daw. So, ang connected sa kanya na edge is ito, 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 at saka ito. That's 4. So, correct? Yung delta D naman would be 6. So, 1, 2, 3, 4, 5, 6. So, 6 edges. Kaya 6 ang ilagay dyan. While yung delta E naman would be this one. So, ang connected sa kanya is 1, 2, 3, and 4. Kaya, yung delta E would be 4. While yung delta F naman, delta F daw is 4. Saan ba yung F? Ito. So, ang connected sa kanya is 1, 2, 3, and 4. While yung delta G naman, yung delta G naman, which is this one, ang connected sa kanya is ito, 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 ito. Kaya, 3 lang ang answer dito. Okay? So, yun lang yung degree of vertex. And that ends our part 1 ng week 13. Okay, so we're done with week 13 part 1, which is mathematics of graphs. Now let's go with part 2 of week 13, which is mathematical systems. Now let's go with the next slide. So at the end of this module, you are expected to. So these are the objectives of today's lesson. So first is we must identify different mathematical systems. Second is understand the modular arithmetic and how it works. And perform operations in modular arithmetic and solve congruence of equations. Now, let's go with the next slide. So let's define modular arithmetic. So modular arithmetic is a system of arithmetic for integers, which considers the remainder. In modular arithmetic, numbers wrap around upon reaching a given fixed quantity. So this given quantity is known as the modulus to leave a remainder. So an intuitive usage of modular arithmetic is with a 12-hour clock. So if it is 10 o'clock now, then 5 hours after or later, the clock will show you 3 o'clock instead of 15. Okay? So 3 is the remainder of 15 with modulus of 12. So yun yung matitira. So, kumbaga, if we divide 15 by 12, which is 12-hour clock, so that would be, so 15 divided by 12. So let's write that down. So that is 15 divided by 12, which is 12 hours. So that is 12. So we have a remainder 3. Therefore, instead of 15 o'clock or 1500 hours ang ilagay niya, instead or makita natin sa orasan is 3 o'clock. Okay? Kung 12-hour clock ang gamitin natin. So, number x mod n is the equivalent of asking for the remainder of x when divided by n. Two integers a and b are said to be congruent or in the same equivalence class modulo n if they have the same remainder upon division by n. In such case, we say that a is identical to b mod n. So, mamaya, discuss natin yan more and deeper. Now, let's have an example on how to solve the modulo or the modular arithmetic or the modulus. Now, ito, usually, no, if we get the modulus of two numbers, so we simply divide kung ano yung nasa left ng mode and nasa right ng mode. And usually, mas malaki yung nasa left, ang value ng left. So, x mod n, diba, yung general formula for mode. So, dapat mas malaki si x. So, but on this case, mas maliit si x or yung number sa left side compared with the right side. So, ano yung formula na gagamitin natin? So, that would be kung ano yung nasa leftmost na number, which is this one. So, yan, 0. Okay. So, ito yung formula. So, yung first number, mag-add ka ng 0. Next is, yung second number naman, which is n. So, that is 4. Then, you multiply that with 0. Then, you add those up. So, 0 plus 0 is 0. And 4 times 0 is 0. So, 0 plus 0 is 0. Now, let's go with another example. Now, 1 mod n. So, yung nasa leftmost, so you add 0, then you add to the quantity of the second number multiplied by 0. So, that is 1 plus 0 is 1 plus 4 times 0 is 0. Same case here. So, pattern yan talaga yan, guys. So, ang palitan nyo lang is yung left or yung value of the number which is left of the mode and yung number which is on the right of the mode. Substitute na lang sa formulang ito. So, this one, that is, the first number is 2, then you add 0, plus, yung second number would be 4 times 0, so that would be 2. Now, this one, ito ang gamitin natin na formula if and only if the first number on the left, like kumbaga yung nasa left ng mode, is mas maliit kaysa sa right. Kung mas malaki siya, mamaya, let's solve. So, this one, ito, 3 mode 4, mas malaki pa rin si 4 compared with 3. So, ang gawin natin dito is the same sa taas. So, that is, the number on the leftmost side of the mode, mag-add ka ng 0, and plus, yung nasa right, which is 4, and is 4, then you multiply it by 0. So, that is 3 plus 0 is 3 plus 4 times 0 is 0, that is 3. Now, on this case, kung magkapareha sila or mas malaki, we can solve for it. Kumbaga, we simply divide the number on the left to the right. Then, kung ano yung remainder niya, yun yung ilagay natin dito. That's the modulus. That's how you get modulus. So, that is 4 divided by 4 is equals to 1. Okay? So, if we divide 4 with 4, walang remainder. So, kaya, yung mode ng 4, Kumbaga, yung answer ng 4 mode 4 is 0. Okay, now, let's go with the next example. Ito, 5. So, 5 divided by 4. So, ito, that would be 1. So, may remainder 1. Kung ano yung remainder, that's the answer for the modulus. Now, this one, let's go with this one. That is 12 divided by 4. That is 0 ang remainder. Kaya, 0 ang nakalagay. Now, let's go with 13. Mode 4, that is 13 divided by 4. So, that is, lagay ko dito 3. So, 4 times 3 is 12. So, yung remainder natin would be 1. So, yun lang yun. So, that's how you get modulus. Now, let's go with more examples. So, this one, modulus 6. So, let's go with 0 mode 6. So, anong gawin pag mas maliit yung nasa left side? So, ang gawin, copy mo yung value ng nasa left side, which is 0. Then, you add 0. Then, plus yung second digit, which is 6. You multiply it by 0. So, that is 0 plus 0 is 0. 6 times 0 is 0. So, 0 plus 0 is 0. Now, this one, so copy mo yung digit on the left of the mode. Then, you add 0. Then, yung second number would be 6. Then, multiply it by 0. That is 1. This one naman, so that is 2 plus 0 plus 6 times 0. That is 2. So, this one, that is 3 plus 0. So, this is applicable if ang left ng mode or the number on the left of the mode, ito, is mas maliit compared sa right. Ito. So, i-compare mo muna. So, that is 6 times 0 pa rin. So, that would be 3. So, yung modulo ng 4 and 6, so that is 4 plus 0 plus 6 times 0, that is 4. So, yung 5 naman, so that is 5 plus 0 plus 6 times 0. So, that is 5. Now, let's go with 6 mode 6. That is, so, yan, parehas sila. So, we need to divide. So, that is 6 divided by 6. So, that is no remainder. Kaya, no remainder. 0 ang nilagay niya dito. Now, let's go with 7 mode 6. So, ibig sabihin 7 divided by 6. So, that is 1. So, ang remainder natin is 1. Kaya, ang answer natin ito. Kuha? Now, let's go with 8 mode 6. So, that means it is 8 divided by 6. So, 1, 6. Then, ang remainder natin is 2. Kaya, 2 ang answer. So, that is how we get modulus. Now, let's go with the next slide. So, same pattern pa rin. Okay, with this one. So, I will let you answer this as I upload the PowerPoint, and let's see if you can generate the same answer as shown in the PowerPoint. Okay, now let's go with the next slide. Same here. So, actually, guys, we can also get the modulus if ang isang number is negative, usually sa left. Pero, yung answer natin will always be positive. Kasi nga, modulus, you are talking about the remainder. Wala kang pake sa sign niya. So, kumbaga, naka-absolute value yan. Okay? So, the same pattern pa rin, may negative lang. Pero, same pa rin ang answer niya with mode na normal, na hindi negative yung nasa left side. Okay. Now, we're done with modulus. Let's go with congruence. So, for a positive integer n, the integers a and b are congruent mode n if their remainders when divided by n are the same. So, for example, 52 is identical to 24 mode 7. So as we can see that 52 are 24 are and 24 are congruent mode 7 because if we get the mode of 52, no, so meaning you divide 52 by 7, that would, no, if we use long division with 52 mode 7, so let's try na. So that, ang ibig sabihin yan guys, patunayan natin na congruent si 52 at 24. So wherein yung 52, if we divide it with this mode, same sila ng answer with 24. Now let's go with 52. Mode 7, so we divide it by 7. So that is 5, 6, 7, 8, 9. Or 8 times 7 is 56. So sobra. So that is 7 times 7 is 49. 7 times 8 is 56. So, yan. So, that is 49. So, yung answer natin, yung remainder natin would be 3. Now, let's try for 24 naman. Kumbaga, dinerecho natin, napatunayan natin na identical pala. Let's see if identical ba talaga. 24 mode 7. So, ibig sabihin, yung 24, you divide it by 7. So, that is 3, 21. So, tatlo. 3 din ang answer. And therefore, they are congruent with each other. So, another way of defining that is that integers a and b are congruent mode n, and their difference a minus b is an integer or multiple of n. That is, if a minus b over n has a remainder of 0. So on this one, let's have this example. So 36 and 10 are said to be congruent on mode 13 because their difference is 26. So if we subtract 36 with 10, so 26, so it is an integer which is multiple of n is equals to 13. So on this one, that is 26 is equals to 2 times 13. Okay? Now, I think we're good here. Now, let's go with the next slide. So, for example, now let's have this. So, 29 is identical to 8 mode 3. So, it's a true congruence because if we subtract 29 and 8, then we divide it with the mode which is 3. So, it is an integer. Dapat yung output is integer, not fraction integer. Okay? So, no worries. Palagi naman positive yung answer talaga kasi nga, we're dealing with congruence. Now, is 15 identical to 4? Mode 6. So, it is not true congruence since 15 minus 4 is 11. Then, you divide it with the mode, which is 6. So, not an integer. Therefore, they're not congruent. Okay. So, let's go with the next slide. So, definition. So, let a, b, and n are integers and n is greater than 0. We write a is identical to b, mode n, if and only if n divides a minus b, where n is called the modulus and b is the remainder. Now, let's have this example. So, 29, which is identical to 15 mode 7. So, let's try. Now, unahin muna natin yung 15 mode 7. So, it means na yung 15, i-divide natin to 7. So, that is 2. So, 14. So, ang remainder niya is 1. Okay? Now, let's go with the second. So, 12 identical to 3 mode 9. So, it is valid since 9 divides 12 minus 3. So, if we subtract itong 12 at saka 3, it is divisible by 9. Dito sa first example kasi, that is 14, mode 7. So, yun. 1 ang remainder. Or we can solve it in another way, kagaya ng ginawa niya dito. So, that is 12 minus 3. So, sinubtract lang niya. So, this is, kumbaga, if we subtract this first example, 29 minus 15, that is 14. Okay? Is it divisible by mode 7 or 7? Correct. So, no need. No, tama yung answer. Okay? Ito na yan. Now, let's try this. So, 12 is it identical to 21, mode 9? So, 21 is a valid remainder since 9 divides 12 minus 21. So, no problem. As long as follow mo to kung ano yung nasa mode. Okay? Now, let's go with this one, the last one. So, that is 12, identical to negative 6, mode 9. So, negative 6 is a valid remainder since 9 divides negative 6 minus 3. So, that is negative 9. Okay. So, that's the definition of congruence. Now, let's go with arithmetic operations of modulo n. So, for addition, ito yung properties of addition. So, if A plus B is equals to C, then A mode n plus B mode n is equals to C mode n. Now, so if A is identical to B mode n, then A plus K is identical to B plus K mode n for any integer K. Third is F is identical to B mode n, where C is identical to D mode n, then A plus C is identical with B plus D mode n. So, number 4, let's go with number 4. So, A is identical to B mode n, then negative A is identical to negative B mode n. Okay? Now, let's go with the next slide. So, it is currently 7 p.m. What time in AM or PM will be in 1,000 hours? So, time repeats every 24 hours. So, we work modulo 24. So, 1,000 is identical to 16 plus 24 times 41. Para makuha niya yung 1,000 hours, kinonvert niya yung mga sagot niya into days or hours. So, the time of 1,000 hours is equivalent to the time of 16 hours. Therefore, it will be 11 a.m. in 1,000 hours. Okay? Okay. Now, let's go with the next slide. Oops. So, find the sum of 31 and 148 in modulo 24. So, 31 is in modulo 24 is equivalent to 7. If we use the first number addition rule, we had that 31 plus 148 is equals to 7 plus 148 is equals to 155 mode 24. 155 modulo 24 is 11. So, as stated previously, 31 in modulo 24 is 7. Instead of wishing the first rule, we'll use the second rule. 148 is 4 in modulo 24. So, now we need to find 7 plus 4, which is 11. Now, let's go with the next slide. So, find the remainder of 1, 2, 3, 2, 3, 4, 32, 56, 22, 12, and 78. Okay? And it is divided by 3. So, we know that 1, 2, 3 is identical to 0 times mode 3 kasi nga exempted. Next is 234, identical to 0 mode 3. Then, next is 32, identical to 2 mode 3. So, let's give it a shot. Paano ba nakuha itong 2? So, paano ba yan? Ang ginawa is, itong number na ito, dinivide sa mode. So, that is 32 divided by 3. So, that is 1, 2. So, we have a remainder of 2. Kaya 2 yung nilagay dyan. Kuha. Okay. Now, let's proceed, no? Ito, okay na to. This one, so 1 divide 3 is 1. Okay? So, 1 divide 3 is 1. So, ganyan yan. So, kaya nilagay niya dito 1. So, if we divide 22 by 3, so that is 3 times 7 is 21. So, let's try if totoo to, congruent sila. That is 22 divided by yung mode 3, which is 3. So, that is 7. 7 times 3 is 21. So, 1. So, yung nilagay niya dito, 1. So, same goes for this other example. So, after that, guys, add nyo lang ito silang 6. After that, is it identical with the corresponding numbers here based on the formula for modular? So, that is 0, 0, 2, 2, 1, 0, 0, and that's it. Okay? Now, so we got, so if we add that 0 plus 0 plus 2 plus 2 plus 1 plus 0 plus 0, that is 5 mode 3. So if we get the equivalent of this, that is 5 divided by 3. So that is 1. So we got a remainder 2. So the answer it would be 2. Okay. Now, this is the properties of multiplication in modular arithmetic. So the first property is if A is multiplied by B, it is identical to C, then A mode n multiplied by B mode n is also identical with C mode n. Now, the second property is if A is identical to B mode n, then K times A is identical to K times B mode n for any integer K. Now, the third property is if A is identical to B mode n and C is identical to D mode n, then A times C is identical to B times D mode n. Okay, now let's go with the next slide. So let's have this example. So what is 8 times 16 mode 7? Okay, so paano kinuha yung solution na yan? So paano ba yan? So ang unang ginawa is kinuha muna yung 8 mode 7, then 16 mode 7. So, paano ba kunin yung mode? If you remember, i-divide lang natin yung 8 with mode 7 or with 7. So, that is 8 divided by 7. So, that is 1. And we have a remainder 1. So, yun. So, since 8, ito yung kinuhanan natin ng mode, yung identical value niya would be 1 mode 7. Okay? Kasi nga, ito yung result natin. Yung pagkuha natin ng 8 mode 7. Now, let's go with 16 mode 7. So, same process na. So, you divide 16 by 7. So, that would be 2. So, we have a remainder 2. Kaya, 2 ang nilagay dito. So, 2 mode 7 is equals to or identical to 16 mode 7. So, we multiply this. Okay? So, that is 8 times B. Diba? So, ang A natin, ito yung B. So, A times B. So, we have followed the property of modular arithmetic. Okay, ito. Okay? So, minultiply lang yan. So, 8 times 16 is identical to itong mga numbers na identical sa kanila. So, that's 1 times 2 is also identical with 2 mod 7. Okay? So, yan. Kinuha lang yung equivalence nila. So, kumbaga, ito sinimplify lang to. Then, ito ang naging result niya. Okay? So, therefore, if we simplify this further, so, that is 8 times 16. So, 16 times 8. So, that is 8. 4. That is 12. So, 128. So, that is 128. Identical to 2 mod 7. So, let's check now. If we divide 128 with 7. So, that is 1. So, this is 5. So, bring down 8. So, that is 5, 6, 7, 8. Okay. So, 8. So, that is 56. And we have a remainder 2. So, kaya, ito yung nilagay dito. So, this is the final answer. Okay? Now, let's go with the next slide. Now, find the remainder if or when 124 is multiplied with 134, 23, 49, and 235, and 13 is divided by 3. Okay? So, we did a similar problem in the previous slide where the signs are all positive and instead of x, or the signs were positive instead of multiplication. So, in that case, manually adding the numbers up would take that much time, though modular arithmetic solution was faster. So, in this example, multiplying the numbers would be tedious. Instead, we use the property tree repeatedly. So, yun. We know that 1, 2, 4. So, kumbaga, isa-isa natin i-divide yung mga numbers given. So, 124 divided by 3. So, 1 ang remainder. So, let's try na. 124 divided by 3. So, that is 4, 12, 4, 1. So, we got 1. So, yun. 1 ang answer. Then, 134 naman divided by 3. That is 4 pa rin. That is 14, 4. So, 2, nilagay niya. Then, let's go with 23 divided by 3. So, that is 5, 4, 7, 8, 7. So, that is 21. So, remainder 2. Then, 49 divided by 3. So, that is 1. So, that is 19. So, 6, 18, carry 1. Bring down 1, sorry. So, that is 1. So, tama yan. So, 235 naman. Divide natin sa 3. So, that is 7, 25, 8. So, that is 24. So, 1 ang remainder. So, ganun ang pagkuha nito. Ito. Yung last is 13 divide 3. So, that is 4, 1. So, remainder 1. So, yun. Nakuha natin yung mga remainders if we divide that isa-isa sa 3. Okay? So, yun. Pagkakuha natin sa mga remainders niya, all we need to do is multiply this, ito, kumbaga yung modulus nila or modulo. So, 1 times 2 times 2, it's 4 times 1 times 1, it's 4 pa rin. Then, the result would be 4. Then, ito, hanapin natin. No? So, may mode 3 na tayo. Ito, for example, wala ito. Kunin mo, bakit 1? So, ang ginawa is 4 divided by 3 pa rin. Okay? So, that is 1. So, yun. Kaya, 1 ang nilagay dito. So, implying the product upon division by 3, it leaves the remainder of 1. So, that's it. Okay? So, that's the final answer. Okay? So ito, more examples, no? So, A mode n plus B mode n multiplied by mode n is equals to A plus B mode n. So, in this one, so 11 mode 8 is equals to 3 and 15 mode 8 is equals to 7. Okay? So, dito, inad niya yung dalawang mode. Okay, so in 11 mode 8 plus 15 mode 8, then mode 8, kasi nga mode 8 yung, or modular 8 yung mode natin, is equals to the adding the 2. So that is, okay, so 11 mode 8 plus 15 mode 8, mode 8 is equals to 10 mode 8 equals to 2. So this one, this is 11 plus 15 mode 8. So that is 26 mode 8. So let's see, let's solve it. Let's divide 26 by 8. So that is 3, 24, 2. Kaya 2 ang nilagay dito. Actually, that's identical dapat. Okay? So, kaya 2 ang nilagay dito. Kuha. So, actually, ang dapat i-execute muna dito is this one, this formula. So, ang ginawa niya, ito, is identical to 11 plus 15 mode 8. Okay? Then, that's 26 mode 8. Then, kinuha na naman niya yung mode nito para makuha niya yung identical value niya. Okay? So, that is 26 divided by 8. That is 2. So, 2 mode 8 is 2. So, yan yung equivalent mode niya. Kaya may 2 sa gilid. Okay? Now, let's have this another property. So, A mode n minus B mode n is times mode n is equals to A minus B mode n. So, yun. Sinubtract lang niya. So, that would be negative 4 mode 8. Okay? So, di ba, if you remember, kahit negative pa ang nandito, positive pa rin yung answer. Okay? So, di ba, this is, mas maliit yung number na ito. So, that is 4 plus 0 plus yung second number, 8 times 0. So, that is 4. Kaya, 4 ang answer. Now, let's have this other property. So, A mode n multiplied by B mode n. Mode n is equals to A times B mode n. So, ito, minultiply lang. So, that is 11 times 15. So, that is 165. Mode 8. So, paano nakuha tong 5? So, obviously, that is 165 divided by 8. So, this is 2, 16, then 5. So, the remainder is 5. Kaya, okay? Now, let's go with the next slide. Okay, so that ends our part 2 of week 13. Okay? Okay guys, so this is part 3 of week 13, applications of modular arithmetic. Okay? Now, this is the objectives, or these are the objectives. Apply modular arithmetic in determining the ISBN check digit and UPC. Next is determine a valid credit card number using a modular arithmetic. Then encode message using modular arithmetic. Now, what is ISBN, or what does ISBN check digit is for? So the check digit is an ISBN number is there to help to prevent errors when an ISBN number is read and entered into the system that is used to deal with ISBN, such as a book catalogizing system, whether the ISBN is entered by hand or by means of barcode scanner. So the check digit as read from the entered number is compared to a check digit calculated from the remainder of the ISBN that has been entered. So if the two check digits are the same, then there is a good chance that the complete ISBN of all of its digits has been read correctly. So yun yung parang, this is the system wherein it reads the barcode. Okay, as an example, if I enter the ISBN 9781861972712 into the system that uses ISBN, it will take the first 12 digits, 9781861972771 of the ISBN and calculate the check digit for the series of 12 digits. So it will came up with the number of 2 as the correct digit and compare it to the number that I have entered earlier, and find that I have entered the number 2 as well. In that case, the chances are I entered the digits correctly. However, supposing I entered ISBN incorrectly and made a mistake by transposing the 5th and the 6th digits entering the ISBN as 978-16819-72712 digit for that number, it will compare 8 with 2 and know that a mistake of some sort has been made, and you won't know where the error is. Only that something is wrong. Mag-error yan. Now, this is the formula for ISBN check digit. So, D13 is equals to 10 minus D1 plus 3D2 or D sub 2 plus D3 plus 3D4 plus D5 plus 3D6 plus D7 plus 3D8 plus D9 plus 3D10, or the 10th digit plus digit 11 plus 3 times digit 12 mode 10. So, actually, may pattern yan. So, alternate lang, dapat 12 siya lahat. So, yung first na digit, wala kang i-multiply. Then, the second digit, multiply by 3. So, 1313 lang yung pattern. That's for ISBN check digit. So, the process is ito. Take the 12 first digits of the 13-digit ISBN. So, usually 13-digit yan. So, yung first 12 muna ang kukunin natin. So, multiply each number in turn from left to right by a number. The first digit is multiplied by 1 and the second by 3 and third again. Paulit-ulit hanggang makarating ka sa ika-12 digit. Then, add all 12 answers. Do a modulo 10 division on the result by step 2, then take the remainder result of step 4, and if it's a 0, then the check digit is 0. If the remainder isn't 0, then subtract the remainder from 10. That's the answer, or that's the check digit. Now, let's have this example, 978-186-1972-712. So, yun, i-alternate lang natin. So, 978 hanggang 1. So, yung 9 multiply by 1, then yung 7 by 3, so on and so forth. Then, yung results niyan, i-add mo lang lahat. So, that is 118. Then, kunin mo yung, i-modulo mo siya, or kunin mo yung mode ng 118 with 10. So, ang remainder is 8. Then, kung may remainder, para makuha mo yung check digit, is subtract mo siya always with 10. So, 10 minus 8 is 2. So, yung check digit natin is 2. So, compare the calculated digit 2 with 1. We entered 2. They are the same. So it looks like we have a good ISBN. So correct. Okay? So yun lang yan. Now let's go with the next slide. So let's have another example. What if na-transpose yung digits? So notice how the 5th and the 6th digits are interchanged. Okay? So ma-change talaga yung result kasi nga nagka-swap sila kasi alternate yung pag-multiply natin ng 3 eh. So the result would be 122. So 122 mode 10 or modulo 10. So 12. So ang remainder niya is 2. So as you can see here, hindi sila magkapares ng check digit. So always no, after we got the remainder, yung remainder isubtract natin sa 10, then ito 8. So hindi magkapareha ng check digit. Therefore, may mali sa in-enter mong ISBN na digits. Okay? Ito. So 8 and 2. So magkaiba talaga mag-error yan. Or ibang product ang, for example, if that's the barcode of that product, ibang product naman ang ma-enter niya. So kaya, 'di ba, may times yung cashier, minamanual niyang ini-input yung barcode kasi nga hindi ma-read ng barcode reader, and if nagkamali siya, mag-error yan. Hindi mag-match sa kahit anong item. So ito. So misread digit, notice how the 10th digit has been read as 3 rather than 2. So baka namali. So mag-iiba talaga yung check digit. Okay? So yun lang yan. Now, UPC, or the Universal Product Code, it is a 12 number that satisfy a modular equation similar to ISBN, and the last digit is the check digit. So yun, ito yung UPC check digit. So 10, digit 12, or 12 digits is equals to 10 minus 3D1. So baliktad lang guys. So 'di ba yung una is ano yun? 'Di ba una is i-multiply by 1 yung first digit, ito baliktad sa UPC. Una yung 3. So 3 times the digit 1, then alternate pa rin. Alternate. So 3D1, D2, 3D3, alternate. Then mode 10 pa rin. Now let's have an example. Let's have this barcode. So if we want to check by UPC, so as you can see here, so 10 minus 3 times 7, then alternate 6, then 3 times 7, then 6, so on and so forth. Then, i-add mo lang yung mga results yan. So, 21 plus 6 plus 21 plus 6 plus 24 plus 5 plus 3 plus 0 plus 15 plus 4 plus 18 mode 10. So, that is 10 minus 123 mode 10. So, kunin natin yung result ng 123 mode 10. So, that is 123 divided by 10. So, that is 1. That is 23. So, that is 2. So, we got 3. Kaya 3 ang answer dito. So, 10 minus 3, ito yung check digit natin, 7. So, as you can see, 'di ba? 12 digit lang yan eh. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Ayan. So, the last digit or the check digit is 7. So, yun, nakuha natin 7. 1, 2, 3, 4, 5, 6, 7. Okay. 11 digit lang pala. Sorry. So, ito. So, 11 lang. Then, yung ika-12 digit, yun yung check digit. So, yung 7. So, tama. Nakuha natin 7. So, therefore, ito is a legit ISBN. Okay? Now, let's have this example again. So, same pa rin formula. So, yun, 39 mode 10. So, 39 mode 10. So, that is 39 mode 10. So, 39 mode 10. So, that is 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 39 mode 10. 39 mode 10, so that is 39 divided by 10. So that is 3, so 30, so remainder 9. So yun, i-minus sa 10, then this is the check digit. As you can see, ito yung check digit for UPC. So sa UPC, guys, is 11 digits lang yung ika-calculate mo inside this one. Then yung last digit would be the check digit. Sa ISBN naman, balik tayo. Sa ISBN, 12 digits, then yung pang 13 na digit is the check digit. So as you can see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yung 2 dyan yung check digit. As you can see, yung pag-solve natin kanina, 2 ang check digit. Therefore, correcto na ISBN number. Okay, kuha. Same here. Now, let's go with this slide. So, calculation of checksum according to modulo 10. So, a check digit according to modulo 10 is used by EAN codes. Examples, EAN 13. So, with the EAN codes, the check digit is calculated according to the modulo 10 calculation method with weighing 3. So, the weighting 3. So, weighting 3 starts from the first digit from the right, then the individual digits are multiplied by the weighting or the weight. These results are added to the sum, and the modulo 10 is calculated from this sum. The first sum is divided by 10, so the remainder of the division is subtracted from 10. The result of the subtraction is checksum or the check digit. So, let's have this example. So, the following is a calculation example of modulo 10 using EAN-13 code. So, for example, the digits are 40076 3 0 0 0 0 1. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So by EAN codes, so 1313 yung weight natin, yung pag-multiply natin. So isa-isa natin i-multiply, 4 times 1, 0 times 3, so on and so forth, hanggang sa last digit. Okay, so that is 4021 69000013. So that is 44. All we need to do is to check alamin natin yung check digit. So, yung result natin would be 44, right? So, kung ano yung pinakamalapit na multiples of 10 sa kanya, yun yung isa-subtract natin sa 44. So, we skip count. So, mag-start tayo with 10. So, 10, 20, 30, 40, 50. Okay? So, yung pinakamalapit na pwede natin i-subtract na hindi magna-negative, yung answer would be 50. So, 50 minus 44 is 6. That's the check digit. Okay? Okay, so that's the final answer. Now, let's go with the next slide. So, determining a determining a valid credit card number. So, to determine whether a credit card number is valid, companies that ID digits are used. Tissue credit cards also use modular arithmetic. The coding method is based on Lon algorithm based mode 10. Normally, credit card numbers comprise 13 to 16 digits long. The first 1 to 6 digits are used to identify the card's issuer. So the Lon algorithm or the Lon formula is also known as the modulus 10 or the mode 10 algorithm, named after its creator, IBM scientist Hans Peter Lon. It is a simple checksum formula used to validate a variety of identification numbers such as credit card numbers, IMEI numbers, national provider identifier numbers in the United States, Canadian social insurance numbers, Israeli ID numbers, South African ID numbers, Greek social security numbers or AMCA, and Serbi codes appearing in McDonald's, Taco Bell, and Tractor Supply Corporation or Co. receipts. So it is described in the U.S. patent number 2,950,048 filed on January 6, 1954, granted on August 23, 1960. So the formula verifies a number of against its included check digit, which is usually appended to a particular account number to generate the full account number. This number must pass the following tests. So from the rightmost digit, including the check digit, moving to the left, double the value of every second digit, and check digit is neither doubled nor included in the calculation. So the first digit is doubled, is the digit located immediately to the left of the check digit. So if the result is doubling the operation is greater than 9, which is 8 times 2 is equals to 16, then add the digits, no, of the result. Example, 16 is to 1 plus 6, 18 is 1 plus 8, 1 plus 8 is 9. So, yung digits niya, i-add mo lang. Or alternatively, the same final result can be found by subtracting 9 from that result. So, 16, no? Sa 16, 16 minus 9 is 7, and 18 minus 9 is 9. Take the sum of all the digits, including the check digit. So, if the total modulo 10 is equals to 0, if the total ends is in 0, then the number is valid according to Long's formula. Otherwise, it is not valid. So, let's have this example. No? Assume that an example of an account number. So, 792739871, that we'll have to check the digit, making it of the form of 799273987 1x. So, yung x yung check digit yung missing. So, as you can see, 799273987 Ang check digit yung last. Then, double every other number. So, yung 7, skip natin. So, every other number, i-double natin. Okay? Then, the sum of the digits. Okay? So, ganito yan. So, nakuha ito. Okay? So, yung every other digit, ito. By adding the first and second digit. Ito, 1 plus 8 is 9. Ito, wala siyang second digit, so automatic 4. Ito din, 6. Ito, 1 plus 6 is 7. Ito, wala siyang second digit, so 2 automatic. Then, we add this, that is 67. Then, the check digit x is obtained by computing the sum of the digits, then computing 9 times the value of the modulo 10. So, the equation would be 67 multiplied by 9. Okay? Mode 10 in algorithm. So, this is the step-by-step now. So, add mo yung sum of the digits, that is 67, then you multiply it by 9. Okay? That's the standard. Then, that is 603. Then, kunin mo yung mode niya with 10. So, 603 mode 10. So, divide mo yan by 10. So, that is 660. So, we got 3. So, ang x natin or the check digit natin is 3. So, yun lang yan. Okay? Now, that's the final answer. That's the check digit of this account number. Okay? So, alternative method. So, the check digit x is obtained by computing the sum of the other digits, then subtract the units of digits from 10. No? So, 67 units digit is 7. So, 10 minus 7. So, in algorithm. So, yung sum digits natin. So, kumbaga, yung second digit. Okay, so the check digit is obtained by computing the sum of the other digits in the third row. Then, subtracting the units digit from 10. So, yung units digit ng sum, itong 7, kumbaga yung tens place, no? 7. So, sinubtract lang sa 10, which is 3. In algorithm, compute the sum. So, ito yung algorithm form niya. Step by step natin, compute the sum of the digits, which is 67. Then, take the units digit of the answer 7, then isubtract sa 10. Therefore, this makes that the full account number is read as 799273987 then 3 ang check digit. Okay. So, the LAN algorithm starts by the end of the number from the last to the right to the first left digit multiplying 2 by 2 all digits of even rank. So, if the double of the digit is equal or superior to 10, replace it with the sum of the digits and realize that the sum S of all digits is found. So, the control digit is C is equals to C is equals to 10 minus S mod 10 mod 10. So example, the number 853x, where with x is equals to 0, the digit to calculate. So take digit 3, i-double mo, so that is 3 times 2, 6. So takes the digit 5, not multiplied by 2. Then take the 8, multiply it by 2. Okay? So 8 times 2, that's 16. Then i-add mo yung 2 digits niya, that is 1 plus 6, 7. So to get 7. So the sum is 6 plus 5 plus 7, that is 18. So 18 modulo 10 is 8. So 1 calculated, that is 10 minus 8 modulo 10 is equals to 2. So it is the digit checksum control. So 8, 5, 3, 2. So kung yung x, value ng x is valid according to LON. Okay? So ito yung kumbaga program niya. Okay, so modulo, kumbaga yung answer is 2. This one. Yung missing digit. Okay? Now, cryptology, it is the study of making and breaking secret codes. So plain text is a message before it is coded. The ciphertext is a message after it has been coded. Kumbaga, cryptology is used to secure a message para hindi siya basta-basta. For example, ma-hack siya. So cryptology is actually used in internet protocol, yung paggamit natin sa internet. Kaya, if we message one another, hindi yan makikita ng ibang users. It is exclusive with the within two users. For example, Facebook, ako at saka kayo, mag-message with each other. They use cryptology para yung plain text na sinesend natin sa Facebook, magiging naka-encrypt siya para hindi siya, for example, makasnoop ang hacker, hindi niya basta-basta mababasa yung conversation niya. So, encryption is the conversion from plain text to ciphertext. Then, decrypt is a message means converting from ciphertext to plain text. Okay? So, ito yung example ng pseudocode implementation. So, ito yung PDF for cytography and modular arithmetic. And that ends our week 13. So, thank you for attending the virtual class today, and God bless us everyone.